This conference will now be recorded.
Okay, so first question is, what is Docker? What is Docker? Okay, so when I read their documentation or ask anyone when I Google it, I see that everywhere they say Docker is a container management tool. Okay, container management tool. See, if I break it down, the definition of each of this stuff, tool means what? Tool means three characteristics which we get from the each tool whenever we use in any year. Using this tool, we can save cost. That's the first thing. And second thing, reduce time for doing something and improve quality. These are the three reasons which we have. So we are using any tool for the sake of discussion. So now the question is, okay, saving cost in what way? In terms of Docker, saving cost in what way? Reducing time in what way? And improving quality in what way? So let me put it up here. If you use Docker and container, because Docker is a container management tool, right? So if you use Docker, you can save CPU, RAM, storage, and operating system cost during running applications. Running applications. Now, guys, understand this way. Uh, is it got disconnected, all of you, guys?
Oh, I can hear you.
Okay, because few people are reporting saying that they are feeling disconnection. So, okay, good. So, saving cost for what? Saving cost for running app during running applications. So, visualize yourself. It's not about your laptop, running application in laptop. It's all about running application at the mass level. Let's say you're running a data center. How many apps you are running? You are running thousands of Apache, thousands of databases, thousands of Tomcat, thousands of applications. So if you are running at those places, then you can save lots of CPU, RAM, storage, operating system, and stuff like that. Reduce time. Reduce time means what? What way here? This tool will help me in what way reducing the time. So if you remember that during the VMs, we were running application in 5 minutes. Now it can reduce to 1 second. Yes, one application you can run in 1 second. 5,000 applications also you can run in 1 second. So this is the way it can reduce the time. I'm just telling you 5,000 application or 1,000 application also you can run in 1 second. I mean it. So that way this tool will help you to reduce the time of running applications from 5 minutes to 1 second. Improve quality means, see, it's very simple calculation. If you are a software engineer and I'm running your application cheaper and I'm saving your time also. Let's say if you want to set up a dev environment, 1 second. If you want to set up a QA environment, 1 second. If you want to set up a production environment, 1 second. So basically, you're saving lots of time, right? So if you're saving a time, then where you'll spend? Of course, you'll spend on the doing better coding and doing better testing, right? That's where you will do that, correct? You will do that. So that way, this tool will help you, Docker will help you to save resources while running application. It will run faster application and will help you to improve the quality of the software. Now, next question I'm having in my mind is called management. Management means what? See, we all understand what is management. We are very good in terms of doing the management, right? So management here in this what context? So management means very simple thing. Management means creating container. Okay, creating container, starting container, stopping container, okay, and deleting container, removing container. This is a management. See, if you go for the any VM's hypervisor, right? Hypervisor means VirtualBox, VMware, or AWS, or Azure, or Google Cloud. What do? You create a VM, you start the VM, stop the VM, remove the VM. So same way, Docker is a also management tool for container. Docker is also management tool for containers. So what you are going to do? You are going to, okay, you are going to start the container. You are going to stop the container. You are going to, remove the container. You're going to create a container. All these things you are going to do through the Docker. Simple. Now, one thing which is I'm not able to understand here. What is container then? What is container? So this is the most important question what we have in this session. What is container? Okay, what is container? My audio is you can hear my voice, right? All of you?
Yes, Rajesh. Yeah.
Yeah, yeah, good. So now the question is, what is container? What is container? So guys, anyone have idea about this? What is container? Anyone would like to talk about it? I would like to know how many of you understand this. Anyone would like to
Maintaining
share
multiple
this knowledge?
servers,
What is that?
maintaining multiple servers like virtual machines in a one container, like running multiple virtual machines in one container.
Mm, no. What is container? That's the question.
Tracking the application and the dependencies which are needed to run the application, bundling them into.
Mhm, mhm. Anyone else?
It's all about virtualization.
Not virtualizations. Yeah. So container means what? Let's understand. Container is running your app. Simple. Container is running your app. Now, next thing is it has it has all resources required required in it. Now, this second statement is very important. It has all resources required in it. Now, the question is next question is what are the resources is required to run any application? What are the resources? What are the resources required to run any applications? Okay. So guys, this is a pretty huge discussion, but because we have a little bit limited time here, I would like to tell you. So first thing, what we required, if you want to run any applications, we required hardware. Simple, all we know. We required hardware. After that, what we required? Software. So this we know that, but we need to little bit deep dive into that. We required hardware, we required software. Software, the first software you required OS. OS has what? Kernel, correct? So hardware, then software. Software starting with OS and then kernel. All of you are agreeing with me? All of you? Hello?
Yes.
So now kernel, guys, kernel has a multiple resources also. We need to know that. We need to understand that. What are the resources we have in kernel? So here we need namespaces. These are the resources. Then we need C groups. We need capability. We need we need C groups, capability, namespaces. So these are the things we need. Now you must be thinking what I'm talking about. So these are the kernel is a what is a kernel? Let's understand this. What is kernel? So I'll just type it. What is kernel? Anyone know that? See here. Kernel is a computer program. It's a code, right? So kernel is a computer program. So namespace also is a program. C groups is also program. Capability is also program. Simple. Not to complicate ourselves. Then you'll ask Rajesh, okay, what this, I know that what kernel is doing at a high level, but what this program is doing, and this program is doing, this program is doing. So I will say namespace also have a multiple kind of program. What program? One of the program which we call it namespace, we call it user namespace. Another program which we have is network namespace. Another we have PID namespace. Other we have one more, I'm forgetting, MNT, MNT namespace. So then you'll ask, what is a user namespace? What is a network namespace? What is a PID namespace? What is an MNT namespace? I'm not able to understand. So let's understand in a simple way. This using this namespace, this program, you can create one user. Okay. Initiate one user. Here, using the net program, net namespace program, you can create one network. One network. Using this PID, using that PID, you can create a PID tree. Initiate one PID tree. Using MNT, you can create one file system, a root file system. Okay, root file system. So now the question was, primary question was, what are the resources required to run any app? Simple. So we need hardware, then we need the software, then we need operating system. Operating system has kernel. Kernel has this many programs. So program is called namespaces. We have these types of namespaces: user, network, PID, MNT. User namespace, user computer program will create one. If you initiate one time, it will create one user. If you create 100 times, then how many users will be created? Tell me. How many users will be created? All of you. See, if you run one program one time, then create one object, right? Have you created instantiated any objects class? Sorry. So if you instantiate any class, you will create one object. If you instantiate 1,000 times, it will create 1,000 object. Correct? No? Agree with me? Hello.
Yes.
Yes.
So same way, guys. It's very simple concept. So user is a computer program. See here, I just stolen the content from the Google. Kernel is a computer program. So kernel is a computer program. Namespace is also computer program. User is also computer program. Net is also computer program. All these are computer program. So if you instantiate one time, one user, 100 times, 100 user. Network one time, one network, 1,000 times, 1,000 network. PID tree, one time you initiate one PID tree, you get it. 1,000 times, 1,000 PID tree. MNT, one time, one file system, you get it, and 1,000 times. Okay, 1,000 MNT, you get it. Okay, are you understanding, all of you? Are you understanding, all
Yes,
of you?
Rajesh.
Yeah. So now there's a two things which I need to clear here because I want you to understand, and that is what is a PID tree. What is a PID tree? So that is important to us to know that. What is a PID tree? So PID tree means process tree. Okay, process tree means every process tree start with zero. They start with zero, then one, then you log in maybe two, you run Apache 3, you run SQL 4, like that. So this is the whole structure is called PID tree. Okay, whole structure you call it PID tree. Let me show you here. Go to the taskbar, task manager. In Windows also, in Linux also, same thing. See here, details. Look at the PID tree. See, starting with the 0, 1 and 2 is missing here because it created some temporary process and disappear. Fourth is running your system, anti-kernel and system. And you see that what is the last PID ID? 29,000. Means this process keep coming and going in a sequence, 1, 2, 3, 4, 5, 6. So let's say if you create one, if you start one application, create one PID and you close that, it will get destroyed. This is called PID tree. Okay, all of you are understanding this? Okay, so this system
Yes.
I'm running from last 2 days. I'm not restarted it, so that's the reason you see that number of paid ID got 29,600 or something. So this is called PID tree. This is called PID tree. Okay, one more thing which you would like to know. MNT means what? MNT means mount file system. What file system? So here I would like to tell you, in the system you have a different kind of file system. One file system we call it a boot file system. Boot file system. Boot file system means it's a kernel. Okay, but here this is not a mount I'm talking about. Some other file system also we have. Root file system. What is a root file system? Let me show you and then you will immediately recollect. Root file system means go to the Google, put it up, show the image, and do let me know if you able to understand what is a root file system. You got it? All of you? Everyone? You got it? Hello?
Yes.
So the files which you see in your operating system, starting with the root, that's called root file system. Simple. So boot file system, you cannot see it because the kernel is hidden, it's running in the RAM. Root file system, you can see that. If you want to see the Windows root file system, let me show you here. Look at this. This is my Windows root file system. C drive, program files, program data. All these are root file system. Okay. Now, one more thing, we have a user file system. Okay, user file system. What is the user file system? User file system, let me show you, then you'll understand. See, this is my user file system. Desktop, my documents, my download, this, that. These are my system, my file system. File system is what? Collections of files and directories. So this is mine. Only I can see that here. This is for me. So if you create a more user, you will get similar. Okay, you get similar, but not the same. This is called user file system. Okay, that is a thing. There's one more file system which we should talk about. App file system. App file system means, I install all of my app in the C drive, tools here. So if you want to see the JMeter file system, this is one app. See that. So guys, are you understanding this file system concept? All of you are comfortable? All of you?
Oh, yes, Rajesh, yeah.
So here, when I'm talking about here, this MNT must mount what file system? So here I'm talking about the root file onwards actually. Root file system. Okay. Now you will ask, Rajesh, what is C groups? I'll not complicate. I'm not teaching you kernel right now. C groups allocates CPU plus RAM to a PID. PID means this is a PID. See here, look at it. You will find it here in Windows itself. You'll see the answer. Okay, let me snip it actually. Look at it very carefully. This is the PID. You notice that any applications which you run, any applications, short process, long process, batch process, whatever, it has a unique PID ID attached. Look at this. And then it has a user also attached. You see that? You see that you never see no user. That means to run any process, you need a user. Look at this. User is never empty. You need a user. And if you see that, each PID, you see here CPU and RAM. So how this allocation happen for each process? So who's doing all this work at a simple level? C groups. Okay. So here, in order to run any application, let's say this is a WhatsApp. I'm running WhatsApp. So what I need? I need a PID ID. What I need? I need a one user. What I need? I need a CPU and I need a RAM. That's all I'm trying to tell you from last 10 minutes. What was the question? What are the resources required to run any app? So I need a one user. One I need PID, and MNT means file system, and network also. This is what I'm trying to tell you. And CPU also. And then this user requires some permission, or this system user requires some permissions. So how do we get it? Capability. Assign permission to user. So guys, actually, if you want to understand, if you want to run any app, you need to have one user, one network, one PID, one mount, C groups for the CPU and RAM, and capability for assigning permissions and stuff like that. Are you comfortable so far? All of you? All of
Yes,
you?
right.
Yes.
Okay, so let's draw the picture so at least we'll never forget this. Okay, so here, this is the hardware. Okay, on that top of that, we'll have a software. Okay, this is software. In the software, we have a kernel. So I'll keep writing also, so understand that. Very important concept, guys. Please focus. Okay, hardware, and then we have a software. Okay, we have all studied. Now software, we have our kernel also. And kernel, we have these many namespaces. So here I'll have a namespaces, network, PID, user, and what? Last one, MNT. And then I have a capability also. Capability. Capability. I have a C groups also. C groups. All this thing you have in the kernel. C group, spelling mistake, please ignore it. All this. So all this thing you have in kernel. Now, if you want to run any applications, what to do? So network, please here understand this. Here, this network is creating one network layer. Why? Network needed because I want to access application from outside. Then this one create a PID tree. This is a network, okay? This is the PID tree. And here MNT mount happen. How many C drive you see that? How many C drive you see that in your laptop?
One.
How many? One. And after that, I'll just, minimize this. See. And then last one, user. Here user. Here user. Something is, so here user. And whatever you have in the mount, applications, PID, network. C groups for the CPU and RAM, and capability for access. And your Apache is running. Correct? This is how you run applications. You see that here. See here, all these applications. Chrome I'm running multiple times. See that. So this is the something which I was trying to ask you. What are the resources? Resources is important, required to run any applications. Let me show you some official image also. Docker, kernel, some image which will help you to understand easily. Look at this. This image is nice. Look at this. See here C groups, namespace, capabilities, rest of the things just forget about it. And here Docker. So did you understand what are the resources required to run any application in a system? All of you? Hello?
Yes.
Now the question is, see the problem, understand the problem. This you are running Apache. Okay. This you are running Apache. So this Apache you are running in the 80 port. Okay, let's say this is Apache. This one user, and is you are running the same Apache 80 port, and the PID is 50. and this Apache is writing in this mount, which is you have here in the C drive Apache directory in one laptop. Think simple always. Don't complicate your mind. In your laptop, you're running. So tell me one thing. If I run another Apache, will I be able to run on 80 port? Tell me. This is a user 1 and this can be user 2 or user 3 or same user also. Will I be able to run on 80 port in the same laptop? What do you think? Another Apache I want to run. Two Apache I want to run in the same machine.
Same port not possible.
Not possible. Why? Because there is only one network here. Remember. Will I get the 50 PID? See that you yourself you check this. Do we have any similar PID? No. Always unique. It's not possible. Same PID also not possible. Same port also not possible. See, if you copy this Apache in the C Apache, and if you copy this Apache also in C Apache, this is a data integration issue. It's not good. So theoretically, in one compute unit, what I'm trying to say, please understand that in a one compute unit, you cannot run two similar applications. Let's say if you want to run Tomcat, that's okay. You can change the 8080 port number and stuff like that, and that probably you will be able to run. But two similar applications you cannot run. So what to do? What to do? Very simple thing, guys. It's a very important concept. What to do? See, how many users you can create, how many network you can create, how many PD you can create, how many amount you can create. Tell me. I discussed this one already. How many? Unlimited. You initiate one time, you get one user. You initiate 100 times, you get 100 user. 100 user is allowed actually. 100 user can you create? Yes, you can create. 100 network, 100 PID and 100 MNT, it was not allowed because of PC concept. But now we will theoretically will do that. Okay. So that means what about if I create a more mount, more PID, more network? That means more C drive, which theoretically is possible. That means what I'm trying to say here is very simple thing. This one more. Again, please, I'm repeating. Look, things theoretically. Can kernel can create a more network? Yes, network. Can create a more PID tree? Yes. Can it create a mount C drive in simple way mount root file system? Yes. Can he create a more user? Yes. Can we attach this user to all these resources? Yes. So now if I run Apache here, can I run 80 port? Theoretically, yes, because it's consuming this network. Can I be the 50 PID? Yes. Can I store it in the C Apache? Yes, because it's using this mount. So if I replicate this feature, one more and one more, and all this is just powered by the same kernel, same kernel, same kernel. Tell me how about this idea? Did you like this idea? That means in the same laptop, I can run multiple Apache, same port, same address C drive Apache, and same PID. So what will happen? For this Apache, I need to have their own resources. This Apache's kernel has to create own resources. This Apache kernel has to create own resources. Are you understanding what I'm trying to say? That means in a one compute unit, you have a multiple C drive, multiple PID tree, multiple network, and multiple user. So multiple application can be run because to run any applications, what you need, one of these. Are you understanding all of you?
Yes.
So the guy's question was, what is container? So I said container is running your app. This guy, think simple, guys. Is this is running my app? Yes, it's running my Apache or any other applications also. Yes, this is running your app. Yes, this is running your app. Yes, and it has all resources required in it. So this app is having mount, PID, user, network. Yes, these are the resources required. Who's managing it? Kernel. So what is this called now? This is called container. Did you understand that in a simple way, all of you? All of you?
Yes.
Okay, my voice is breaking for everyone, or because few people are complaining voice is breaking or something like that. Or is it okay?
Yes, there is a break. There is a break now and then.
Okay. I'm using the same setup. Not sure why. Uh, maybe it's breaking to a level where you cannot understand or something.
No, I can understand that.
Okay. Okay. So guys, what is container? Did you understand that? All of you, tell me. So guys, container is running your app. It has all resources required means it has a network resources, it has a PID resources, it has a MNT resources, it has a user resources, and here MNT means what? MNT means root file system plus user file system plus app file system. That's called. So in this container, please understand that many people say think container is a VM. No, it's not a VM. In the VM, you have operating system. VM model, you have operating system. Tell me, did you find any operating system here? No. Operating system, there is only one here. Okay. So it's not a VM. Okay. So it has all the requests required in it, network, PID, MLT, and user. And this is how you get it. So now guys, what is Docker? So Docker is a container management tool. For what? For we are using this tool for reducing the cost and time for running application. Management means what? You can create container, start, stop, and remove. What is container? So container is nothing but your app, which has all the resources required, and these resources are user namespace, net namespace, PID namespace, MNT namespace, C group for the CPU and capability for the access. So now, I hope this is clear for everyone. So now, guys, this tool is written in Golang. Now, who's the father of this tool? So the father of this tool is Solomon Hykes. This guy. Yeah, you see, he is the father of Docker. He invented this kind of architecture. I mean, Docker, and he's the father of it. Okay, so Docker has multiple releases. One is the community edition, which I'm teaching you, community edition, and another we have enterprises. So guys, I request you to ignore that some of the typo if I made it, because I'm just typing it to make it the flow simple. The challenge what we have is Docker is pretty vast topic, but I'm trying to put it in a my way. So in the next 4 hours, it can be covered all the topics, so you will not get lost out. So it's an enterprise. I'm teaching you community. Now you want to know the difference between Docker community and Docker enterprise. So simple trick I'll teach you. Docker community edition and versus enterprise. and then end of it, it's type DevOps tool. You will find my blogs. See here. This is a blog, DevOps School, Community Edition versus Enterprise. Though it's not required for you to learn in detail, but at a high level, if you have interest. Okay. So what is the version of Docker which we are learning? So version of Docker which we are learning is 22.x. Okay. This is the 22.x. Okay. So this is the container management tool written in Go by Solomon Hykes. Release has two kind of release, community enterprise and version 20x, which we are learning. Now, next question I'm having in my mind is Docker is the only tool or other tools also we have for that? So it's not like that. There are so many tools which can create a container. So many tools. It's not a Docker is not alone actually. So we call it container runtime environment. Okay, container runtime environment, and that's where just put the DevOps tool. That will be easy for you. And here you see these are the environment which you have. So other tools also we have which you can check it out. But right now our focus is on Docker. So let's not deviate from that and learn from that stuff. Okay, so that is a thing. So all this URL I'm putting in the notes. So end of that I'll share with you and get going. Now next thing is Docker architecture. I want to know architecture of it, how it works actually. Okay, Docker architecture. Okay. So far so clear, guys. Any questions? Any doubts you have? Anyone?
So,
I hope I'm
Rajesh,
not. Yeah, tell me.
this is Anil here, Rajesh.
Yeah, Anil, tell me.
Yeah. So, will you talk about how the container works internally with respect to isolation? I mean, it could be a deep dive, but are we covering it here?
How
See, basically,
can you just little bit?
yeah,
Huh?
I'll tell and explain. So, basically, as you said now, like, container is like an isolated environment which only requires a process
Huh?
ID, which is nothing but a logical thing. Physically, it might be
Huh?
a memory, network, a disk. Right? These are the basic things like a care and feed of any process, right? With respect to noise.
Mm-hmm.
Now, the difference
Right.
between a virtual machine and a container is like container picks up runtime libraries and then does the job and then releases the resources back to the operating system or the base machine or the Windows or the VM, whatever. So this is the actual story,
With him. So is it something
right? Yeah.
for all, or is only happening for me,
Sorry. Can you hear me?
guys? Yeah, your voice was breaking for me. I'm not sure whether it's happening only for me or for everyone.
Sorry. Yeah, I can hear you clearly.
Yeah. Okay.
Yeah. So
Fine.
I was talking. So I was talking like will be discussed about how the container really works, like the real difference between a VM and a container. Like at high level, we all know that VM needs an OS. It's a full-blown OS. The container is
See here, very
basically a
simple,
runtime
very
environment.
simple
So
thing. So we discuss actually, but let me remind you. I'll put it in one more image. Okay. So this is the hardware. Okay. and on top of that you have a kernel operating system. Now what we do?
Yeah.
What we do? Can you see my screen?
Yeah, I can see actually. So I've heard about what you said. I was talking about like just take an example and how does
Just
really a
just
container.
just just a second. Hold on. This is the hardware. This is the kernel. What we do? We install hypervisor. Hypervisor means VMware, VirtualBox, and stuff like that. After that, we create a VM. So in the each VM, what we have, our operating system. This is the operating system. So this is the VM model. Okay, I'm not able to draw right OS. Yes. Now what happens after the OS? What happens? OS, because this is the kernel you have here also, here also, here also. So then we create a network. Then what? PID tree, MNT, and then user, and then running an app. So this app, the one which you are seeing that, is using these resources. Again, here you have a same thing. What another OS, other VM, and running your app. In the other VM, also you do the same thing. You're running your app. Now, what is that? Right? Hello?
Voice is breaking actually for me.
Hello? I'm not sure
Your
people are
voice is
able to hear
breaking,
me or not.
Rajesh.
Yeah, voice is breaking.
Is it breaking?
Yeah.
Yes,
Yes,
Rajesh,
Rajesh,
it's
it's
It is.
breaking.
It
breaking.
is
Okay, let
breaking
me
actually.
change the headphone. Yeah, so you have to tell me, guys, because
Yeah, that's what we are saying. Your voice is breaking.
what about now?
Now go on. Let's see.
Voice is clear but somewhat low.
Hello, is it audible to all of you?
Yeah, now it's clear.
Yes, now it is clear and loud.
Oh, good, man. Thanks.
Now it's better, Rajesh.
Yeah, I changed the headphone. So yeah, do let me know whenever you face some issues because we all are connected through the virtual. So yeah. So guys, what I was discussing, you have a hardware layer, you have a kernel, you have hypervisor like a VMware, and then you using that you create a system, and then inside that operating system you have a network, PID, and MNT and users. So far clear, right? All of you? Hello.
Yes, Rajesh.
Yes,
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 it
Rajesh.
is clear, Rajesh. Carry on.
Hello. Yeah. Now this is a heavyweight, guys. Remember that. If you look at this whole diagram, one app, two app, three app. For running three app, how many operating system you need? One app, two, three, and here also four. And heavyweight hypervisor you need. Now we are changing the architecture. This is the hardware, and this is the kernel. And kernel will look at this here. No operating system. Here we have something called Docker, which is lightweight, and here we are having network MNT user. See here, these all are MNT user. See here, MNT user. So this is the network, this is the PID, this is the MNT, and this is the user.
and application is running, application is running, application is running. So you see that what you saved from this architecture to that architecture. So basically, see, ultimately what I was trying to tell you, this is important. What are the resources required to run any app? So these are the resources required. So what kernel has given, here they are managing all the resources, and isolation is managed here. This is one container, this is one container, this is another container. So each container feel as if it's independent. They have their own C drive. I'll put it in simple way. They have their own network. They have their own pit tree. But ultimately, the kernel is handling. So here what you are avoiding, multiple layer of operating system. So here you required 3 operating system to run 3 app. Here you required only 1 operating system to run n number of app. Are you understanding now?
Yeah, good.
Yeah. So now my topic was, what is a Docker architecture? So Docker architecture means, first thing, every architecture we have a human. So we will talk to whom? So we talk to Docker client, and Docker client talk to Docker server. Docker daemon we call it, server also we can call it. Okay, Docker daemon, and Docker daemon talk to the container D, and container D talk to the kernel. This is a simple architecture, you can think of it. So human means we, client means you understand there is a client which can send this right command from the human, because if you send the bad command, then it will be a problem for the server. So to filter the right command from the human, we have this interface. So we send the command whatever we wanted to client. Client send this command to the Docker server. Docker server send the command to kernel D, container D, and the container D send to the kernel. So this part we call it, usually we call it a Docker engine. So guys, you know what? We've been talking Docker is not right word actually. You know what? Because Docker is a company name. So the product which we are trying to say, I want to learn Docker means you want to learn Docker engine actually. Because Docker is a company name, they have a multiple product actually altogether. Their first product is Docker engine, so it's become very popular. So actually we are learning Docker engine actually. Okay, now we'll say, Rajesh, what is containerd? So understand that Docker is not allowed to talk to kernel directly. Okay, so everyone, look at this here. Everyone uses who wants to talk to the kernel for container requirement, anyone. So they will use the container D. So container D is one utility, again open source utility. This is the industry standard container runtime. That means industry standard means anyone who wants to talk to the kernel for the container requirement, they will use the container D. The Docker also is using the container D. But you know what? Before container D, they were using some other library, and probably that image you have seen that. This one. See, libvirt, LXC, systemd and spawn and all, it was used earlier, but now containerd. So this is the architecture. So we will send a command to Docker. Hey Docker, please create a container for me. And this command will be sent to the server. And this server will send this command to the containerd. And containerd will create, send to the kernel. And kernel will do what, you know, we will create one. Please understand that kernel will do what? Create one network. Okay. Create one mnt means all these file system. Okay, mnt, this one. Okay, mnt means root, user and app. Okay, please remember, not a boot, because I said very clearly in the container you don't have a boot, you have only root. So here you have a root, here also have root, here also you have root. In the mount, one mount with a root. Okay, and then here create one user, and then last one create one what is that, I forgot that. NSMNT user and pit tree, correct now? And then at the end of it, what they do, attach user with network NS plus mnt, same mnt, and then same pit. and that's become a container. That's a container. That's all. Are you understanding, all of you? Hello? Hello?
We here.
Yeah, Rajesh, you
Yeah.
can.
Yes,
Yeah.
Rajesh. Yes.
So that's a container. So this is architecture, guys. Docker architecture. Now next thing is how to install Docker. How to install Docker. It's very simple thing. I will not talk, but I will show the demo. So from here onwards, we will use the demo. So let's use one of the my VM which I'm having. So I'll just type Docker install, okay, and DevOps. Enter, and here this installation instruction. Though you can follow official documents also. That's good. So this is the place where you have three ways to install Docker: YAM, or RPM, or script. I'll use the script because that way it's easy. You have to write little bit less command, and I'm very lazy in that. So this is my machine which I'm going to show you the demo, and 109, that's IP address, right? So here, where's the shell? Here it is. So I'm just going to log in, and guys, it's very simple though. It's not that difficult. And SSH root at the rate of 192.168.1.9, right? And login 1.109. Sorry, my bad. 109.
Rajesh, can you zoom a little bit?
Yeah, I'll do that. 0.109. Enter. Rajesh 123. Okay. So by the way, this font style is very big. Probably if you set this, the view also for what is it? Go to meeting, then it'll be, you have a multiple view for that. So view check this in the full view. That will be easier for you. Okay. Are you? Is it visible to everyone?
Yes.
Yeah. Good. Okay. So now, guys, what I'm going to do? I'm going to install the Docker. So let's run this command, and then so this script will install the Docker. I don't have to worry about all this command running manually. This is CentOS 7. Okay. So Ubuntu also same script will work, no problem. Anyone have any question meanwhile?
I'm sorry for the interrupt, Rajesh. Would it be a silly? But I'm asking you, like, are we going to install an like CMD or else like in a shell only? Like
CMD
shell.
means?
I mean command line. I mean like the tool
Okay, what I
console.
did, I log in as no. I what I did, I log into one of the Linux box, which I am
Okay.
having running in the laptop itself, and then
Mhm.
I'm running the command in the my Linux box using this git bash.
Okay, fine.
Yeah, I'm not running in the Windows. I'm running the one of the VMs virtual machine, because remember that as per the architecture, Docker maximum needs is kernels. You see that? So Docker needs kernel. That's all. So kernel I have in the laptop also, and I have in the VM also, so I can use it anywhere. Okay, so guys, this is done. Okay, installation is done. Now after that, I am going to enable it, so you can use it for the next time also. Enabling is not required though, and then restart this Docker process. That's all, and done. So now, how do I validate? So let me show you here architecture. Look at my screen. My screen is visible, right? All of you.
Yes.
So I'm a human being, Docker client. Where is the Docker installed? Which Docker? See that. Here it is. This is the client, okay? Where is the Docker D? Which Docker D? Which Docker D is here? Whether it's running or not, ps-ef grep Docker D. See, it's running. And container D. Which container D? Container D. Whether it's running or not, container D. See, it's running. And kernel, you know that it's running because of I'm able to access. So this is the installation instruction. Now the question is, okay, I install this, and which document I follow? I follow these documents. I did that. Oh, why we got this? Huh. So this is the documents. But now the next question is, what is a Docker? What is it? Life cycle. Life cycle. And then last one, container workflow. Sorry. Opposite way. Container lifecycle, Docker workflow. How Docker works, and container lifecycle, which I'll tell you. So Docker workflow means simple thing. I have been telling you. You know that. Little bit of revision of this flow. I will do that. Okay. Little bit of revision. Okay. We send the command to Docker client. Docker client sent to the Docker D. Now Docker D, before sending a command to container D, you know what they do? Docker D will check. Please remember that. Docker D will check if Docker image exists locally. The question is, what is Docker image then? What is Docker image? Are you having that questions also? All of you?
Yes, Rajesh.
Yeah.
Yes. Yes.
So guys, for that to answer, we need to know Docker components, which we did not discuss. Components. So in the Docker, you have four components. One is Docker engine. Now, I believe we understand the Docker engine because I showed you also this is the two things, Docker engine and how to install it. Second thing is Docker image. Yes. So I'll not complicate too much, but I'll put it in a simple way. See guys, when you create a virtual machines or no matter where you are creating, you are in creating laptop or AWS or Azure or anywhere else. So when you create a virtual machine, then you need what? You need a VM image, correct now? Virtual machine image. You need a VM image. So similarly, when you create a container, remember that, understand that container is think simple. Always think simple. This application need to be stored somewhere, right? So where is that? So it's there in the MNT. MNT. MNT means mount. So what you see inside a container, what you have in the mount. But the question is, what is the mount? So mount come from the Docker image. So still I'm not able to understand what is Docker image. So I'll put it in a very simple way. But before that, I will simplify this VM image. Okay, so VM image is equal to boot file system. Boot means kernel, root, user, app. All I explained it to you. So any VM image you will see, it has a boot plus root file system also they have it. Root means Ubuntu, Fedora, CentOS, RHEL, Debian, Windows 10. These are the root file system. Then you will say, Rajesh, no, you are wrong. These are the operating system. See guys, change little bit of the understanding when you are in the world of container and Docker. See here, there is a two kernel in the whole world. okay, which we use a lot. Which one? There is a Windows kernel which power all the version of Windows, and there is a Linux kernel which power all the version of Linux. So when you say Ubuntu, it's not operating system. Actually, it's a variant of Linux, flavor of Linux. And this flavor, Ubuntu or CentOS or whatever it is, you are using the kernel which is Linux only. But on top of that, what they did, CentOS added the yum utility and Ubuntu added apt utility, like that. So it's like that. So here in the VM image, you have a boot file system plus root file system plus user file system, and then you may have applications also. Now, when I say, if I simplify this, boot means what? Boot means your kernel. Root means what? Root means anything which is starting from here. That's a root. Users means what? Means it can be user Raju, and here app means what? It can be Apache. So this, the VM image may contain this Apache plus Java, anything it can be, n number of software. So this VM image may contain all this from the boot, root, user, and app. Are you comfortable with the VM image at least? VM image which you are using from last 20 years. Are you comfortable?
Yeah.
So guys, the question was, what is a Docker image? So guys, Docker image contain only from the root, from user, and app. Here. Understood? What is the difference between VM and Docker image? So VM image contain root plus user plus app. Okay, so don't correlate that root with the operating system. Okay, so when I say this time Ubuntu image, Ubuntu Docker image, that means you know what, you will have Ubuntu root file system only, and plus some user plus some app. Okay, so root file system is a starting point for the any Docker image. For the VM image, kernel is a starting point. It can be Windows kernel, it can be Linux kernel. So now guys, what is happening? One image. So what is happening? Please here understand this. When we create one container, what happens? One container. So one copy of image get mounted into container. This, see, I'm repeating one mount, one mount, one mount, one mount. So what was one mount? This is the one mount. That means here, if you look at this, this is the container, this is a container, this is a container, this is the mount, this is the mount, this is the mount, and this is the mount. This, what is a mount? So mount is nothing but this one copy of the image. Whatever the Docker image we have, one copy of image mounted at each container. So that's the reason you see that whatever you have in the image, you see inside a container. So if you have image Java and Apache, then you will see in Apache. If you have Java plus Tomcat plus X plus Y plus Z, you will see those software. If you don't have, then at least you will see this one. This is called root file system, base image. Are you understanding, all of you?
Yes.
So guys, now the question is here, see and understand that for creating an image, so for creating a container, the image is important, because mount coming from here only. Now the next question, next component is Docker registry. Then you'll ask, what is a registry? Simple. Registry contains repository, and repository contains version of what? Of file system. That means what file system you're talking about? I'm talking about this one. So here registry means repository. It has a repository. Repository will contain the file system. Which file system? Root file system, version of root file system, user file system, and applications. So this is called registry. So Docker Hub is a registry. Yes, it's a registry. GitHub is a registry. Docker Hub, see here. Docker Hub is the one public registry. Google registry is a private registry. Google registry You can create artifactory also. Many options are there. I'm using Docker for Docker Hub for this demo, where we can have a repository will have a file system will have these are the versions. GitHub is also registry in that case. Okay, GitHub has a repository you have a files versioning is done of the file system. Same way. So guys, the third component is Docker registry, which we are using Docker Hub. Let me go and make you a little bit comfortable with it. So go here, search for it. This is the Docker Hub. And please spend some time. You can create a free account and all register, How many applications are there? How many images are there? Look at this. How many images are there? See, popular image like Nginx. So Nginx means what? Nginx means it has some sort of root plus user plus Nginx. Let's say if you go for the Ubuntu means only root. Let's say if you go for MySQL, that means MySQL means some root plus some user plus MySQL, like this. Are you understanding what is the image and what is the registry? All of you. So image you get it downloaded from the registry. Are you understanding? Hello?
Yeah.
Yeah.
Yeah. So guys, how many images are there? Don't worry about that. You can have you private registry also like Nexus, Artifactory. Artifactory I'll teach you as part of this session. If you are on AWS ECR, it's AWS ECR. So many products are there for the hosting the Docker. I mean Google Docker image. So many products are there. So let's not get lost. So here first component is engine. Second component is image. You have to have it for creating container. Image you may download from the registry or you can create your own image. I'll teach you how to create image. And the last one is Docker container, which we discussed already. Okay, so now these are the four components. So here what I was trying to tell you, Docker workflow, when you say, hey, you are a human being, you say Docker, hey Docker, please create one container from this image. Which image? You can say this image, let's say Ubuntu image, traffic image, Redis image, Nginx image, HTTP image, whatever, I don't care right now. So then Docker D will first check if I have that image locally or not. If it's not there, then it will download first. Docker D will download from where? Default, this place. You can customize this also option. Let's say if you're using Artifactory, then you have to change the path of the registry. Okay, default registry is hub.docker.com. So it will download the image from here and then keep it in the local, and after that they will send the instruction to the container D and kernel, and then image will be created. So here the mount, the one which we are talking about, is nothing but one copy of image. See here, one copy of image get mounted into the container. That means if you want to create a 10 containers from one image, yes, possible. I will have to create 10 containers, so 10 copy will be created from that image. Simple. So guys, this is a workflow which I wanted to tell you. Now the next topic which we have is container lifecycle. What is a container lifecycle? See guys, you keep it very simple, okay? Always keep it very simple. When you are using, I don't know how many of you are using a doc image, virtual machines from or not, because this is something which is there, this technology is there from last 20 plus years. So what do you do with the VM? So you create a VM using the image, and after that you start the VM, then you stop the VM. Okay, and then if it's stopped, then again you may start the VM. Look at the logical flow. Okay, start the VM, you can restart also, you can then kill that, you can also again kill, after that again you start that, and after starting that you can also pause that VM, and then you can unpause the VM also, unpause the VM, and finally just a second guys, here. So finally, if you can stop it, already done, kill also done, again you can stop it, and after that remove that. So tell me, this flow is having any flaws, logical flaws? All of you, are you understanding the VM world?
Yes, yes.
Yes, Rajesh.
So guys, is there any flaws in this problem? This flow? Hello?
No, Rajesh. No.
Simple, right? So you've been doing from last 20 years. If you're experienced software engineer, if you're some of you may be from the fresher background also, so it's time to learn. Nothing else. So what we need to do? Same thing with the container also, guys. Nothing great. We need to create a container. You need to start the container. You need to stop the container. We need to start the container again because it's what to stop. You need to restart the container. You need to kill the container. You're going to start the container again because you kill this again. You're going to pause this container. You're going to unpause the container. You're going to stop the container, and you can remove the container. You can remove the container only if you can stop the container and stuff like that. Very simple. Not too complicate. Why too complicate? So can I do that? So guys, first thing I need an image. So how do I need the image? So some of the basic command I need to run. What command? First Docker command. And see so many commands we have got it. Your job is to learn all these command.
Hi Rajesh, Saurabh this side. Sorry to
Yeah,
bother.
yeah.
Actually, I was trying to ask this question, but my mic was not working. So, how can we install
Yeah.
this Linux machine and Docker over a iOS device? Is that
See,
easier?
you have to use the VMware or VirtualBox. That I'll teach you next weekend. That that
Oh,
topics I'll cover the next weekend. Okay.
okay, fine.
And else I'll just budge you some of my previous recordings also, so you can create. Why to wait for 7-8 days for that? 5-6 days for that.
Sure.
Okay.
Yeah.
Okay, so now what I was doing, I forgot. I was doing something. Yeah. So I was running some of the basic commands for the Docker, right? So Docker, just Docker and all this command you have run. Docker help is also, it's a great command. You should practice. Don't depend on someone else. Depends on yourself. All commands, all the documents are available on the command line. Why not to use it rather than googling here and there and getting lost? Ask this tool itself, right? Now Docker, which version? So I want to know the version, right? So it's a 20.x, it's not 22.x. Okay, my bad. So I wrote 22.x, but installation was happen 20.x. Okay, I need to check whether 22.x is there or not. Maybe I mistyped because Kubernetes 24. So maybe because of that relationship, I said 22.x, but it's 20x. Okay, now I want to know how many images I am having in this machine. So Docker images, I have none. You see, repository, tag, image ID, created, size, none. I want to know how many containers I'm having running. None. I want to know how many containers which is in exit state. None. Nothing is there because this is fresh machine. I just got it for you. So nothing is there. So these are the command I should run and I should get comfortable. I want to know one more command which is Docker info. Docker info. Now let me tell you very straightforward. Whether you understand this output or not understand, please read it at least once during the lab. Okay, don't ignore it because I cannot explain it to you each and everything, but it's a logical. And even though if you don't understand, read it at least. Next this time you read it, next time you will be having in memory. When you are doing the things, you will recall that okay, I found this information at this place. Docker info is every information about the system with respect to the Docker, you will get it. So run this command and understand that. Okay, so these are the command which I am going to ask you to run it. So here these are the commands I run it. Sorry. So I am running this command. Now the question is which image we should work. So guys, I don't care about the image. You can use any image for the sake of it. Which image I should download. So you can download any image. I don't care. So here you have so many images. How lakhs of images are there. Lakhs of images are there. You decide what you want to run. What application you want to run. You decide. You want to run Ubuntu or this, or you want to run something else. Search for it. Let's say I want to run Apache HTTPD. Do we have image? Yes, we have an image. You see the filters, great filters are there. You can do that. HTTP official images are there. So HTTP is like Apache image. It's a web-based application, so it's easy to do that. So how do I download that image? Docker pull HTTPD. That's all. So automatically it will download from the hub.docker.com, and you see that this. If you look at this here, this command, they have this command here also. Pull means pulling that image. Which image? HTTPD. From where? Default hub.docker.com. It's pulling. It's small image, so it will be pulled sooner. I'm from working from home today, so it'll be done in few seconds. Done. So I got the one image already. How do I see that? Images. See, each image has a is from the repository tagged with the image ID 10 days ago and size also. I got an image. What to do now? I have to create a container. How to create a container? I need to follow the workflow life cycle. How can we do that? So let me do that. It's very simple. I want to create a container. Docker create from what? HTTPD. Created a container. Can I see that? No, it's not there. Why? It's because PS command will only show you running container. It will show you all containers. ps-a for all container id. Each container will have a unique id from the image running with the created status and name of the container and stuff like that. Can I give the name of the container this time? Creating one more container. Hyphen name, right? And hyphen name or hyphen name, I just, okay, Raju 1. Yes, created one more container. See, this time I named it Raju 1. So if you don't name it, it will take it random name, but it will be unique all the time to the host. So I got the two containers. You want to create one more container? Raju 2. Done. And here you see, I got the three container. I told you, you will get everything in 1 second. So how much time you will spend to create a container? Nothing. You know that. You saw that just now. What to do now? Start. Look at the status column only. Okay, Docker start. You can use the container ID also. Okay, for starting the container, you can use the container ID. You can use the container name also. Start this container. Look at this. Is up. Okay. Okay. Are you understanding, guys? All of you. One container is running. See here. Can I start the Raju 2 also? Docker start Raju 2. Done. See up. Are you able to understand that, right? All of you?
Yes.
Yes.
So guys, I got the containers. What to do now? I'm going to stop it. Which one I want to stop it? I'll stop the Raju one. So Docker stop Raju 1. And see, if I stop the container, we'll get exit. See, first time you create, it will be created. The any container which has run at least once, then you'll have exit state. And it's still running. Still running. Clear the screen. What to do? Then start again. Which one? I'm going to start this again. Raju 1. Simple command. See, starting. Done. Up. Now what to do? Restart. Which one? I'll start the Raju 2. First one. Restart. Done. See that timing status up 1 second. Raju 2. Restart. Can I kill that? I'm killing this Raju 1. Okay. Kill that. See that exit again. Kill and stop. Both you can do that. Now you have to find out. This is a task for you. You have to find out what is the difference between kill and exit. Practice it. Sorry, kill and stop. Practice it and do let me know in the next session. Okay, keep a note of it when I give you assignment. Okay, so this is done. What to do? Again, you are going to start it. Raju 1, I'm going to start it. So can you do that? Raju 1. Start it. See, again running. What to do? Again, Poch. So I'm going to Raju to Poch. Poch, Raju, Raju. Running container you can Poch. What is a Poch? What is unpoch? Technically, you should try to find out that answer. What is a poch happen? What happens when you poch? What happens when you unpoch? I'll let you find out. Just take a note of these questions and give me the answer for this. So it's poch. Look at the status. Poached. Can I unpoch it? See. And what to do? Can I stop it? So I'm going to stop it two containers together. Raju 1, Raju 2. Container ID also you can use it. Name is easy. Spelling I mean there's a typo. See, I stopped both the container. See, both exit and both the containers I'm going to delete it, which is the last step. Alright, done. And then you see that here. So tell me one thing. Did you find any difficulties working with the container? How much time it takes? You know that. So this is the workflow commands which I run and for you, and it was very simple. Are you able to understand all of you?
Yes, right.
Now what to do? See guys, when you run VMs, tell me one thing. Think and tell me, okay? I want this answer for you. When you run the VM virtual machines, what do you do? What do you do? When you run, let's say EC2 instance, you run on AWS or some VMs on Google Cloud or Azure or in your local boxes, or someone give you some boxes IP address and password or whatever it is. Then what do you do with that VM virtual machines?
We first try to log in.
So you do two things, okay? Either you log in and work through interactive way. That's one thing you do that. Or what you do, you access the application which is already installed in that VM through HTTP or something like that. Correct now?
Yeah, for that we need to know that the application is running inside or not. For that we need to log in.
So let's say someone say, let's say I will tell you. I'll tell you in simple way. I have a one image which has all the applications already installed. I just created a VM out of it, and automatically it will start running because I enable that services. No, correct? No.
Correct.
So the moment you create a VM, everything is running. Pre-configured VM from the image itself. Image itself it had everything. Correct? No?
Correct.
So then what you need to do? You will access that application and you will use it just like a Facebook. You log in and start using it just like a Instagram. So what I'm trying to tell you here, when you get VM, either you log in and work interactively, or you access that application which is running inside that from outside. Some protocol is there like HTTP or something like that. HTTPS. Makes sense, right? Correct
Yes,
now?
correct.
Okay, one more thing, guys. I will ask you one more question. Okay, tell me when you work with the Linux or Windows, and don't tell me console based. You have to forget when you are in a DevOps world. You need to forget the console now. You have to always remember the command line. So when you log into Linux, you are a human being. Okay, remember you are a human being. I'm also a human being. When we work with the Windows or Linux through command line, how we interact with it? How do we interact with the system? How human interact with the system? Anyone have an answer for it?
Basically with the keyboard.
No. Keyword me. Okay, probably I'm confusing you my question. Your system is running actually, and you human interact with the system like Linux or Windows through some utility. What is the utility name?
Through the
T.
commands.
Which one?
Through the commands.
Okay, I'll put it in a now. Okay, I'm trying to say, hey, you connect with the Linux, but you interact with the shell, right? Bash shell, corn shell, C shell, and stuff like that. Correct, no?
Yeah.
Without a shell, you can't interact with the system. You are a human being. Same case with the Windows also. When you interact with the Windows, you have to interact with the PowerShell. Okay, forget about the console I'm talking about. Correct, now? Right? Okay. So now the question was, let's do that. Because I run the container, I'm okay. But how to use it? That's the question. So here, guys, first question is how to go inside a container and interact with it. That's the first question. Okay, guys, I'll request you to all of you to mute yourself if you're not speaking. Okay. Okay, I'll just mute. Yeah. So how to go inside a container and interact with it? And the next question is how to access a container from outside. Very simple. Container from outside. That's the two question I'm going to answer to all of you. Okay. So how do we do that? So first thing, understand that there are two ways. One is exec and there's one attach way. So exec means what? So here using exec command, you can execute, understand that, you can execute any executable. Please read this carefully. I am writing it a little slow, so you have to read it. Okay. So you can execute any executable inside a container. Yes. So can I do that? Let me do that. So right now I have some containers, which is Docker ps-a. There's a created. I'm going to run this container Docker start, and this container I'm running right now. See, it's running. So now I want to run some commands inside this container through exec. How do I do that? So first thing, Docker execute and this container name or ID, and then ls. See, this command I'm running inside a container because the output which you got it is from the running inside a container. So can I run this command? Oh, sorry. See, failed. Why? Because this command is not in its executable is not available inside a container. Simple. Can I run something else? df. See, can I run the ps? See, ps executable is not there in this image. So using exec, you can run any commands inside a container. But the question was not that, right? The question was how to go inside a container. So let me tell you here. You can execute bash with IP interactive way, and you can go inside a container because you are a human being. How can you interact with something with a machine without a shell? Bash means, I'm saying bash, you can use any other shell also, but nowadays we are using, all of us are using bash, so it's okay. So what to do now? So guys, here we have a container. I'm going to execute docker execute what? Interactive way. Which container? This container. What you want to execute with? Bin bash. So that means this command will help me to go inside a container. Enter. Tell me, where are you right now? Where are you?
Container root.
We are inside the
No,
container.
Inside the
no,
container.
not. You are inside
Container.
a container, guys. So let me show you here. ls docker. See, docker is not there inside a container. So you do not run. You cannot run. See, ls-root. See here. So I told you in the container also you have a same root file system. Why? Because one mount each container. Okay, PS is not there unfortunately, so I cannot show you. But W is also not there. So many utilities are this lightweight image of HTTPD, production ready image. So many utility which is not required to run this application is not there. That you can do that. This is a good practice. LS is there, so I run it. DF is there, I guess. Yeah, it's here. This is inside a container, okay? So what to do? Exit outside of the container. And you see here, ls, df, du, ps, all this is there in my VM, but not it was there. Few utilities were not there in the side a container. Are you understanding what I'm trying to say?
Yes.
Yeah. So this is the something which we need to know. So what I wanted to teach you, how can you go inside a container, and you know that how to go inside the container. Then you say, Rajesh, okay, I know that exec, but what about the attach? So attach, you know what it will do? Attach to PID1 of the container. Now PID1 is what? So PID1 is the first container. Because of that, please hear me out. I'm not writing it. PID1 is the first process. Please understand that. One more time I'm repeating. PID1 is the first process inside a container. Because of that, your container is running. If that PID1 is not running, your container is not running. Please hardcode this statement. I said PID1 is not running, container is not running. PID is running, container is running. If PID will killed, you will be killing that PID1, then you will exit the container. Exit container will be exited. So here, if I put it in a simple way, to conceptual way, then go to this one. And this is your machine, right? So in Linux, PID1 is the major process, but here you don't have major process. In the major process, here you have PID4 in Windows. That means if I put it up in simple way, if PID4, which is a system, if I kill, then my system will be shut down actually. Okay, they see that you can't end this. Are you understanding?
Yeah.
So if you kill this somehow, this PID4 in Windows, then your system will shut down. There is a way to shut down. So ultimately what they will do, they will kill all this process, and then ultimately they will kill this process also. So in a container in the Linux world, PID1 is there. So PID1 is making this. Let me show you that in Linux, my VM. Where is my VM? Is here. So forget about the container. Look at the VM's runtime environment. Okay, I'm showing you. Look at this in the VM. So many software I'm running, and look at this one. So this you are running a kernel of your VM, PID1. So same concept we have in the container. Don't give so much of importance to the container. So container have the same runtime. Remember, virtual machine also gets the one PID. Each container also get a one PID. PID map, PID tree. I said right, tree starting with 0. See, one the parent is 0. So what I'm trying to say here is, attach command will attach to the PID1 of the container. How do I know that? So let's do one thing. I can't work without few utility, so I have to install some utility. So what I'll do, go inside a container, whether it's apt or yum, I'll just find out. Yes, wonderful, it's apt update. I'm updating the container. Apt update also. I'm updating the container, remember that, because I need a utility. I can't show you without that. Okay, so here done. Now I need apt install ps. Yes, I'm guessing that utility will come from the PS. I need a PS utility. Oh, it's not there. So what to do? Apt install PS. So the utility, the package name is proc PS. So PROC PS. Now I got the PS also. So you can install just like you. I'm working just like you are working in any machine. any Linux machine. Okay, so now I got the PS, guys. Look at my screen here. See here, this is the PS. Look at the PID one. Are you able to see that, right, all of you?
Yes.
So what I was trying to tell you here, I installed the PS, so I can see that PID1 is HTTP foreground. So what I was trying to teach you, if you do the attach, it will attach to the PID1 of the container. And here, this is the PID1. What is this? HTTP foreground. Okay. So you know what? This process, if this process will kill, you know what will happen? Your container will exit. So remember that important statement I am making it. Container is running as long as PID1 is running. Please remember that. Container is running as long as the PID1 is running. PID1 is not running, container is not running. Simple. You kill the container, container will exit. So now you will ask, Rajesh, how do I set the PID and all, PID1 and all? Now this is the part of the development activities, and those who is developing an image, they know that how to run applications also, and they'll keep the PID accordingly. Okay, so during the creation of the image itself, you'll set the PID1. There's a process CMD and entry point, blah blah. You do that? But right now, don't get lost for time being. So what to do now? I'm going to exit this container and docker ps-a. See, the container is running. This time I'll do the docker exec. And what is the container ID? Oh, sorry, not exec, attach. Sorry, attach. And here I put the ID. Oops, what happened? Many people, in the session, they think my system command got stuck. I'm not doing anything. I'm typing. Nothing is happening. Commands are not accepting. What to do? No, it's not stuck. Where you are? Where you are? I showed you already PID1. You are at this place right now because you attached to that session of the. So you attach to the container. That means when you use the attach command, you attach to the session of the container. So what to do now? Can't do anything. You are on the PID1, and PID1 don't understand your all this command which you typed it. Because see, you're a human being. Your command is understood by the bash shell, not by this HTTPD utility. HTTPD don't understand any of your command which you are typing right now. So what to do? So either I kill this session, the container will also get killed. If I kill this one, because I'm on PID, and if I kill this session using the control C or control Z, then PID1 will get exit. PID1 will get exit. Container will also get exit. But I don't want to do that. I want to show you something else. What? I'm logging with some other session 192.168.0. Whatever the IP address, I forgot. Anyone remember that? How do I get it? Yeah, it's here.
109.
So IP 109. Yes, you have very sharp memory. Appreciate it. So here 109 and Rajesh 123. So now you see that the container is running again. But what to do? So I'll just go and get the IP address of container. How do I get it? Inspect command. Remember, inspect container ID, and I'll get the IP address. Now I will request you to read everything. Whether you understand or not understand, that's a different thing. But read everything because it's your learning process. Gradually, you will get to know everything. So here I came here to only grab the IP address. My IP address is this one. So look at my screen, guys, all of you. And here I'll just call access this HTTP IP address, enter. See, you see the background setting the application as Apache and is creating a logs for that. Understood? So basically you are on the PID one. Now if I want to come out of it, kill this. Your container also got killed, you see. Because I told you, right? PID1 get killed, container got killed. So here, what I was trying to tell you, attach will get attached to the PID1. Usually you use this command for troubleshooting of the container output and all stuff like that. So yes, the question was how to get inside a container and interact with it. You can use exec and attach also for attaching, but you have to kill this container for troubleshooting. So these are the commands which I run in order to display some of the things. I must show this here. So guys, so far so clear, right? All of you? Any questions? Any questions? Hello? Any questions? Okay. So guys, next question is how to access the container from outside. So actually I answered this. But actually, you know what? I can access this container. Think simple, okay? From the same box which I am having, curl, I can do that. But what's the fun accessing the container from the curl? Can I access this container from my browser? Uh, let's see. Oops, not accessible. So, did you understand the problem? Anyone? So, I would like to know how many of you are there in this session because people get, you know. So, can you confirm me if you are
Yes,
in
sir.
the session, all of you?
Yes.
Yeah.
Okay, I'll ask you one question. Let's say, think simple always. Don't complicate yourself. Think simple. My question to you, all of you, let's say you are running some application, let's say Apache in your laptop. Can I access it? Let's say I'm somewhere outside, I'm your neighborhood. You are using the same broadband, I'm using also same broadband. Okay, from the same ISP provider, let's say Airtel. Okay. So if you're running Apache in your laptop, can I access from my home? I'm having different connection. You have a different connection. So can I access all of you?
No.
Why no? The why no? Because the networks are different. The scope of the networks are different. You are running. See, you have a Wi-Fi. I am having Wi-Fi, but the scope of my network is limited to whatever the devices connect to my network. I can connect to that. But your scope is different. Different. You remember that the whole world is filled with LAN. Your LAN, my LAN, everyone else LAN, and they are connected with the WAN, and they decide like we should be outgoing, we should be ongoing. All this thing, bridging, routing, all this thing. So basically, I'll just draw a picture and then you'll understand that. Okay, so it will be easy for you to understand and me also. So here, this is your laptop. Okay, this is your laptop. Oh, sorry, this is a VM. Right now I'm using VM for running the Docker. And this is a VM, and then this is your container one. This is another container two. Okay. Now you know the scope of this container networking. Right now I'm not teaching networking, but just little bit of it. The scope of this container is only limited to the host only. That means if I'm here, I can access this one also, and host also. But if I'm outside, then cannot access this VM. Sorry, this container. I can access the VM. This is the see. I can access the VM, which I am doing. See, I'm doing the SSS, right? That means I'm accessing the VM, but the container is running on the different network. I cannot access it. Why? The scope is different. This container is on a different network, and my host is on different network. And the scope of this network is not allowing you to connect from outside of the host. So it's all about the scope. Yeah, all of you have a scope. Your scope is not allowing, so that's the reason I cannot connect to your network. It's like that. So what to do now? See, the theoretically I can connect to the host machine, but I cannot connect the container. What to do? So between this container network and my host network, there is a bridge. Okay. So can I create an exception in the bridge? We call it a port forwarding actually. So that means what I'm trying to say, hey, I will connect to my host, and I will request my host, hey host, because you can talk to the container also. Can you please transfer this traffic to my container network? Can you do that? Are you understanding, all of you? All of you?
Yes, sir.
So what I'm doing the port forwarding in AWS also. you do the port forwarding. Azure also port forwarding. Google Cloud also port forwarding. I don't know how many of you have used it, but you remember that in AWS also you get a 2 IP address. Azure also you get a 2 IP address. Why? So one for IP
Public
address
and
for
private.
the public and private. Yes. So public is like not permanent. So what they say, hey, you hit the public IP address, and from there we will redirect the connection to the private IP address. Private IP address is the real IP address. They use it to the port forwarding. Same thing we are doing at the smaller scale. I can connect to the host machine, yes. Host machine can connect to the container, yes. So this means can I connect directly to the container? No, because scope of the container network is limited to the local. So what to do? I will go ahead to the hit the container host port, and host port will lead me to the container port. That's all, and then I can access. What to do? How to do? So for that, what you need to know little bit of it extra things. What extra thing? You need to know one command which is called run command. Then you'll say, Rajesh, what is a run command? You are not answering me directly the answer how to access the container from outside. So you need to know this command because this will save lot of your time. So what is a run command? So run command is equal to pull plus create plus start plus attach. Do let me know if you understood or not. Pull means creating pulling the image, creating container, starting the container, attach. Just now I explained it to you, attaching to the PID1 of the container. So that means if you run this command, it will do everything. If you run any image, it will do all this thing. Now you'll say, Rajesh, I don't want to attach. What to do? Nothing else. You have to deattach. Run -d and then do not attach. Are you understanding, all of you? What is the run command stand for? It's a shortcut command for saving time. Make sense, all of you?
So in the real world, like in a work environment, and if you're asked to install and create a Docker, this is the process you have to go through.
Yes, I'll do that in front of you. I'm not going to run pull, create, start, attach. It's like irritating work actually for me. What to do? Simple. Look at my screen here. So here Docker run httpd. Remember, it will do attach also. So enter. What happened? You are on side of PID1 because I told you it will pull, create, start, and attach. So you are attached to the container PID1 and this HTTP. Same thing I showed you. Attach the PID1. They don't understand anything. I will kill this container. And you see that here. This got killed also. This is the one. But this time I'll do the little bit clever work. I don't want to see. -d means detach, 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 and see the magic. How many containers you have? See, I wanted to have one, two, three, four, five. How many? 6 container within a few seconds. See the power of Docker. 6 Apache, you got it within few seconds. You want something else? Let's say SonarQube. Simple. It's pulling that image. You look at this. Run, I said, it will pull that image. Java, OpenJDK, Jenkins, Jira, Nexus, Artifactory, Ubuntu, CentOS, RHEL, anything you just run. You might have seen that run is being used everywhere. Are you understanding, all of you?
Yes, Raj.
So guys, this is the way we work. See how much time save. You wanted to install SonarQube. I just got it. Just pulling is taking time. It's a one-time activity. But after that, just a second. Sorry. Just wait for a few more seconds. Almost done. And you see the magic. Download cut finished. and then container is with you in few seconds. See, done. So did you get it? Container or not? See Sonar Cube, first one. You want one more Sonar Cube? See, one more, one more, one more. So look at this. You want whatever you want, you get it. Now, if I do the run Ubuntu, then you see that what happens. Ubuntu image. It will download again and same. So now you understand that run is a magical command. We should use run itself all the time. Okay, so this container will exit, run and exit. You know why? Because in the Ubuntu image there is a PID one which is not keep on running. So that's the reason it will exit. See here. See here. It's not running Ubuntu. Why? Because exited. It run and exited. So what to do in a Ubuntu case? Because PID one is not running. This image is designed like that. It will do the work. See here. It will do the work. ls I want to run. Output. Okay, D you have to remove it. Just a second. See here. It performed the output and then exited it. Why? Because in this image there is no as such PID one which is designed to run all the time. So it's running and exiting it. So what to do? Nothing. You have to do -itd to make it running. That means you are making this container always running, and so on. And Docker PS. You see that how many applications I'm running for the no effort. So now you see Docker PS. See Ubuntu is running now. So guys, this is the way you have to work. Run is a magical commands. So now you know what, my system will get slow. I don't want my demo to be spoiled. So I am going to apply magical commands which will stop all the containers. So Docker stop and remove all containers. So there's a command for it and I'm going to use it. Which one? For that I'm going to use this command. Docker, this command. Stop all containers, okay? And then finally remove this will remove all containers. So it's stopping, just wait for a few seconds. And stopped, remove. Because you cannot remove the running container, so you have to stop it. And you see here, no containers. So within a few seconds, I created all the container and then used that and then deleted it. But the question was not that one. Question was how to access the container from outside. And for that, what you have to do, Docker run and http d and -d. This command you are comfortable, right? All of you? Hello? This command you are comfortable, right?
Yes.
So
Yes.
what to do to access the container at the host port? I need to do the port forwarding. How? -p option. This is the host IP address and this is the container IP address. This is the host IP address 81. Container will remain same. This is Sonar Q. I forgot that port number 9000. Yeah. So this is the 82 and 9000. It's a built-in port number. Let me run this and where is that? Here it is. So here done. This magic happened, and then see that here 2 and last one 3. So 2 Apache, 1 Sonar Cube. I want to have it. Docker ps-a. See, remember one is 80, 81, 82. Let's check it out. What is the IP address? And you have to disable the firewall also. This machine is disabled actually, firewall day. But I'm doing just for you, so you will Some of the people get stuck easily. So for time being, till you get pro, disable the flag bar. It's not good practice though. You have to
Are you
create
gonna share
instance.
the cheat sheet with us? The notes?
Yes, yes, yes,
Okay.
yes. I'm going to show. So this is the 80 board, okay? And I am going to access 81. This is also Apache. And 82 I have a sonar queue, right? See, this is a sonar queue. So easy. Life has become so easy now with the container. No effort I am doing to running every application. Okay. So this is the command. This is the question which to answer how to access the container from outside. So you can use using curl also locally IP address, but expose that to the outside, and then you can use this. Okay, so now I'm going to store this command in the notes so you'll remember that. Are you understanding, all of you?
Yes.
Yes.
Yep. So this is the commands. So guys, let's do the recap. It's very simple though. We understand what is Docker. So Docker is nothing but a container management tool, saving cost, saving time, all these things. You saw that in front of yourself. What is a container? I will request you to spend a little bit more time here, and I have a few recordings for few hours on this kernel only, so you can check this out. But yeah, if you want to get started, then this is sufficient discussion. One time also you watch this recordings, whatever I said, in the different context. If you know the kernel little bit, and this component, will be easy for you to understand the anatomy of container. This is very important. Okay, many people get confused with this. So remember that in the Docker image you have only root, user, and app. Okay, and then other architecture also, and installing the Docker, then workflow, I explained it to you. Then components which include engine, images, registry. From there we download the image, and container. What to do with the container? So regular basis you will do this one only, and sometime you get lazy like me, then you will use run, which I showed you here somewhere. And how to access the container after running. So also I have showed you through exec command, attach command, and from outside if you want to access, then -p and all. So all these things. So these are the sections which we have covered so far. Using that, you can access the container, and I mean basically you can work with the Docker and create a container and use the container very effectively. No problems. You can use the container very effectively. So all these are very simple commands to get started with it. Now, you know what? Next section which I want to teach you is like how to create an image actually. Because you have learned, let's put it in this way. Phase one is like learning the bicycle, and you understand all this bicycle component like clutch, brake, this, that, lights, and all, which I taught you just now. But now I'll teach you how to assemble, how to manufacture the bike. That means next time when someone will ask you, hey, I need some this image. This image means I need Java, Tomcat, JBoss, this XYZ, Flana, Dimka, whatever you want. You can create your own image and give it to him, and he will just run it simply. So that's the next topic I'm going to teach you. Any questions before that topic? All of you?
Nothing.
As of now, no questions.
Okay. So guys, let's have a break now. We'll have a 15 minutes of break. Grab your tea, coffee, restroom, and personal calls, and come back in 15 minutes. Same meeting ID, and then I'll teach you how to create an image, Docker image, and how to share an image with other also. For example, we can upload that image to hub.docker.com also. Okay. So I'll see you after the break. Bye everyone.
Okay.
You.
Hello, sir. Hello, sir. Hello, sir.